All right, guys, so we are now taking a look at the exponential equations from graphs. So previously we did the linear equations, right? So now we're going to do the exponential equations. So in these ones, all we really are looking at now are the graphs, okay? And to start us off, so these first 8 questions are examples. So we're going to work through those ones together. Then we're going to have some time where you can work through, and then we can kind of check our work, okay? So remember, we've got 2 different types of equations. We've got the ones like this one on the left that is a growth, and we've got the one on the right that's decay. The growth ones are timesing by a number. The decay, we are dividing by a number, though when we write the equation, we're going to be timesing by its reciprocal, like the fraction, okay? But both of them follow that same format, y equals a times b to the x, where a is our y-intercept, and b is what we're our factor, our growth factor, we could call it our rate of change, okay? So what we need to do is we need to figure out first the y-intercept, then how is it growing, is it timesing, is it dividing, and by what? Then we can write the equation, okay? So that's kind of the format that we're headed here. So first thing to probably do is to kind of plot all those points you've got going on here, especially the ones you can really see, okay? So if we look at number 1, I would plot this point, -2, 1, then -1, 2, then 0, 4, which right off the bat, we should see that's our y-intercept, right? So y-intercept is 0, 4, or we just call it 4, right, for the graph. Then the point 1, 8, and 2, 16. Okay, since I'm moving to the right one, really what I want to focus on is kind of that growth. Let me actually erase this. Okay, so we're looking at how is this growing. Okay, and if you need to, it can be useful to kind of draw these lines and see that, you know, this is 16, this is 8, 4, 2, and 1, which I should be able to notice, okay, 1, 2, 4, 8, 16, that we're timesing by 2. So that's our constant ratio, that's our growth factor. So for my equation, I go y equals, we start at 4, then we times by 2, we make our 2 have that exponent because that's our growth, okay? So probably the hardest part about this is finding that growth, all right? So let's take a look at number 2. Now we've got a decay function here, okay? Again, plot all those points, so that's got a y value of 3. Now I'm not seeing any very good points here, am I? Okay, look for points that you have. Okay, 6, 12, and that's kind of really all I see, isn't it? Well, we know my y-intercept is right here, right? At 3. Okay, now let's think about that growth. So this distance here is 12. Okay, then this distance is 6, then 3. So as I go from 12 to 6 to 3, what's happening? Okay, well, you could say, well, it's cutting it in half, which is exactly right. So I'm dividing by 2. Okay, now we could essentially write our equation y equals our start of 3 divided by 2 to the x. However, we want to get in the habit of when we write the equation to do the reciprocal. Okay, so dividing by 2 is the same as timesing by 1 over 2. Okay, so my equation probably should look like y equals 3 times 1/2 x to the x, I should say. Okay, I usually put the fraction in parentheses. All right, so it's going to probably look something like that. Okay, now if you need Mr. Vorwaller to pause this, if you're watching it in class, ask him to pause it so you can keep up with the stuff. Okay, but that's kind of all we have to do. So there's a few things that you have to write down, and I would write all over those graphs to make sure that you're getting it, okay? So let's do a few more examples and kind of just check ourselves, okay? So again, first step I would do is I'd plot all those points and find their y values, okay? The points that are easy to. Points, when I say that, I mean like how we have at a coordinate, not like in between, like these ones, okay? So I've got 16 here, I've got 8, 4, 2, and 1 for my y values, okay? If you need to, write them out, and write them in order of left to right, or else you'll get it wrong, okay? Because I know this one should be a fraction because it's going down, it's decay as we look left to right. So 16 to 8, 8 to 4, 4 to 2, 2 to 1, we're definitely dividing by 2 again, which, for our growth, we should say is actually timesing by 1 over 2. Okay, no matter what this dividing is, put a 1 over it, and that'll give you what you're timesing by. Then we see our y-intercept is 4, so I'm going to go y equals 4 times 1/2 to the x. Okay. Again, let's look at 5. It's another decay one. So again, I plot those points. So that'd be 15, 7. This one's going to be difficult. 3. And then notice here, it looks like my asymptote is clear down there. Okay. This is when we shift the asymptote. So this one's going to be troublesome. Okay. So maybe we should get back to this one then. Okay, so we can talk about it in terms of 5 and 6. Okay, so let's look at number 4 instead. So I look at those points. So we have it at 16, we have it at 8, we have it at 2. Oh, and 4, and 1. So it goes from 1 to 2, which 2 is our y-intercept, so there's our start, to 4, to 8, to 16. So we can see we're timesing by 2. So I start at 2, so I go y equals 2, timesing by 2, and then I put my exponent up there. Okay? So that's kind of the basics we're looking at here. Okay? Now, 5 and 6, and it looks like 7 and 8, we've got some issues going. Okay, normally we said, or I guess generally, the asymptote, right, that invisible line, is the x-axis. The only time it isn't is if we're going to shift it up or down. So we look at 5, it looks like my asymptote is here at -1. So what that means, from our x-axis, it got shifted down. So everything got shifted down 1. Okay, so if I look at this number, this, and this, what I want to think of is that they've just been shifted down. Okay? So what I need to do is actually the opposite and add 1 to each number to help us figure out where it's, what the growth actually is. Okay? So it's actually 16 to 8 to 4, which would be dividing by 2. Okay? So I'm going to go y equals, okay, so it should have been, my y-intercept should have been up there at 4, so we'd start at 4, and we should be dividing by 2, or timesing by 1/2, right? Timesing by 1/2, okay, to the x power. Now there's one more thing that we're doing, we're subtracting 1 from it, so I put subtract 1. So that's what my equation should look like. Now, we generally don't throw these ones at you, but we are kind of taking a look at them this time. Okay? So again, notice where it looks like your asymptote is, where it flattens out. So we're subtracting 1. So I'm going to go y equals my start times my growth to the x, and I'm going to subtract 1 to it. Okay? So we know we're doing that part. Now, because we're subtracting 1, all of these points are going to be off by 1. It's like my original graph, if we shifted it, you know, would be up by 1. Okay? So all of these points should really exist 1 up. Okay? So really, this y value should be 1. This one should be 2, this one 4, this one 8, and then this one would be shifted up to 16. So really it's 1, 2, 4, 8, 16, which means I'm timesing by 2. But because we shifted everything down, that throws my numbers off, doesn't it? Okay, so we should have started at 2, our y-intercept, so we'd go y equals 2, and we're multiplying by 2 to the x, and we're subtracting that 1 to represent what our actual graph is, okay? Because you got to remember, when we shift those graphs up and down, it's going to adjust those numbers, okay? We need to hurry and look at that on Desmos again to remind us what that looked like, okay? So, again, the idea, so let's say it's y equals, we had what, 2 times 2 to the x, okay? And we are subtracting 1 from that, okay? So we have y equals 2 times 2 to the x, which is our original, and then y equals 2 times 2 to the x, and then let's put a plus k here and add a slider, okay? We should probably also do a y equals k. Kind of shows that asymptote, right? Except let's make this go dashed. All right, so the idea here is that we started out with that red one. That's what our graph looks like, right? And k would actually be down right there. And my goodness, can't get it to stay on negative. Oops. 1. Close enough. Okay, so originally our graph looked like this. Okay, and we had this point right here as our starting point. Okay, as we can see when our asymptote was at 0. Oh my goodness. Hold on. Let's do some stuff here. Make this work easier. Okay, so there we go. So when it was at 0, okay, we had this point right here. But as we shifted that k down, okay, our points all shifted down 1. So because of that, we have to represent it by pushing it back up, because that -1 right there is what is dragging it down, okay? So that's kind of that visual that we have going on here, is that we're shifting it down, or we could be shifting it up, but we're starting from that same one, then we're shifting it down or up in whichever direction, okay? So this part of my graph remains the same. It's the other parts that are different, okay? So the growth and the start, that's all the same. It's just been shifted up or down. And we represent that kind of with how we were doing this, okay? Because, as we looked at number 5, those numbers don't show us that we're dividing by 2, which is really what we are doing, okay? So that's what makes it kind of difficult. All right? So 7 and 8 are shifting as well, okay? So 7 looks like we're shifting down 1, okay? So we're going to have to take that into account. So we've got our y value of 0, our y-intercept of 1, of 3, 7, and 15. But because of that -1, really, originally, these were all shifted up 1. So that really should have been 16. That really should have been 8. That 4. This one 2. This one 1. Okay? So that's our actual growth factor, which, as we can tell, we're dividing by 2 or timesing by 1/2. Okay, and our start would actually not be at 1, it would be at 2. So I'd go y equals 2 times 1/2 to the x. That's our original graph, but then this one that we have got shifted down, got pushed down 1, so we have to put the -1 to represent what is actually our graph. Okay? Now we look at number 8, and this time we're shifting it down 2. So as I look at these points at 1, 4, 10, and so on, okay, they are actually being shifted 2, so they originally were up 2. So originally that would be at 3. And this up 2 would be at 6. And this would be at 12. So originally my points would have looked like this red line. Okay, but because we shifted everything down 2, it shifted all these numbers down. So really what my numbers were starting at 3, that was our y-intercept, then 6, then 12, which would be times them by 2 here. So I'd go y equals 3 times 2 to the x. Then we shifted everything down 2, and then I'd put a minus 2 there. Okay. So that's kind of tough to deal with, but that's how we deal with those ones. So we did want to talk about them today. Now, you've got some problems yourself to work on, so you're going to have this video paused, and you guys are going to work on these. Now, if we look at 9, 10, 11, 12, 13, 14, so to 14, okay, those ones are not going to have those shifts. So you guys should all be able to do those ones, okay? If we struggle with the last 4, that's all right. So why don't we pause it and have you guys try to get to question number 14, okay? So the teacher there, Mr. Vorwaller, will decide if how long you guys need before you play this and check your work, okay? So pause it now, and then when you're ready, let's see how you did. Okay, guys, so you should have already gotten to at least question number 14. So let's look and see how you did. Okay, so if I'm looking here, we got the point 12, 6, 3, and then it's hard to tell, right? But I should be able to tell from going to 12 to 6 to 3 that we're dividing by 2, or timesing by a half. And that our starting point was 3, so I'd go y equals 3 times 1/2 to the x. Okay, if you put 3 divided by 2 to the x, we'd still count that, but we got to get in the habit of putting that fraction when we're dealing with graphs. Okay, so there's number 9. For number 10, this one's kind of harder to see at times, so we've got a 3 right here. And it's really hard to tell where the rest are, isn't it? But I'm thinking it was up here at 18. And sometimes our graphs are hard to tell right there. So if you got a different number, I apologize, but I think this here should have been 3. I believe at 18 is where we would have been. And this here then would have been at 1/2. Okay, so that was probably a tough problem to deal with. Okay, but basically we've got 18 to 3 to 1/2. Well, 18 to 3 we'd be dividing by 6, wouldn't we? 3 divided by 6 gives us 1/2. So our growth is we're timesing by 1/6, and our starting is at 1/2. So this one was a really tricky one, wasn't it? So y equals 1/2 times 1/6 to the x. Okay, so if you didn't get that one, that's all right, because that is definitely a lot more difficult. Okay. All right, 11 and 12. Okay, so again, I think we're here at 18, down here at 6, and at 2. So we go 2 to 6 to 18. So we should be able to see we're timesing by 3, and we're starting at 2. So y equals 2 times 3 to the x. And we're done with that one. For number 12, looks like we've got 1, 2, 4, our y-intercept. So y equals 4 times, and 8, and 16. So 1 to 2 to 4 to 8 to 16 we should recognize pretty easily. We're timesing by 2 here to the x. All right. Okay, now 13 and 14. We've got 16, 8, and you can see we're kind of using a lot of the same numbers. All right, so 16, 8, 4, 2, 1. Definitely dividing by 2 or timesing by a half. Starting point of 2. So y equals 2 times 1/2 to the x. Okay, and the last one you should have got to, that's going to be hard. That's either 1/3 or 1/4. Then it looks like we've got a 9. Okay, so my guess is it's probably 1/3. Okay, when we quiz you guys, we're not going to give you ones like this. Okay, so 1/3 to 9, we'd have to be multiplying by 9, right? No. Oh my goodness, what are we multiplying? Oh wait, I missed one, didn't I? I missed this right here, which looks like that is 1.5 or 1.5. Okay, so we go from 1/3 to 1.5 to 9. That's a tricky one. So if you didn't know, you could just take that 9 and you can divide it by 5. Okay, so, or by 1.5. So 9 divided by 1.5 is actually 6. So we're times them by 6. So 1/3 times 6, that gives us 2. That's weird. Maybe 1/4 times 6. It was 1/4. Sorry, my bad. That's a tough one. Again, we won't give you crazy ones like this. So it was 1/4 to 1.5 to 9, so we're times them by 6. And we started at 1/4, so y equals 1/4 times 6 to the x. If you didn't get that one, that's all right. If you struggled at it, I'm sorry, but sometimes struggling is helpful. Okay? All right, now the last 4 are those ones that are going to shift. Okay? So again, think about how it's different, shifting up and down. Let's talk about it one more time. Okay? So let's actually, we'll do 15. So this is shifting down by 1, okay? But then I look at my points, so that looks like it's probably about at a 4th. Then that would be at 1. And then it looks like we are at 16. Oh man, I'm killing you guys on this assignment, aren't I? Okay, so 1/4 to 1 to 16 is what I'm seeing. Okay, but remember we subtracted by 1, so everything should really be shifted up. So this should be 2. So maybe this was actually 15, and it'd shift up to 16, and this would shift up. I guess that was -3/4, wasn't it? It would shift up to 1/4. So we go from 1/4 to 2 to 16. So we're times them by 8 here. And our starting point was 1/4, so we'd go y equals 1/4 times 8 to the x minus 1. Wow, that was a tough guy. Okay, so take some time, try these ones, just give it your best shot, okay? And then we will talk about them, okay? So pause it again, give yourself some time, and then watch this after. All right, that should have been sufficient time to probably really struggle. So let's take a look at these. So 16, we can see our asymptote has shifted up 2, which means all these points actually should have gone down. So we've got 10, 6, 4, 3, and looks like 18. So really, that should go down 2 to 16, down 2 to 8, down 2 to 4, down 2 to 2, and this 3 down 2 to 1. So the 4 was our y-intercept, so our y-intercept would be 2. 1, 2, 4, 8, 16, times them by 2, so it's y equals 2 times 2 to the x plus 2. A lot of 2's in there, huh? Hopefully that one was a little easier. Okay, again, if you need a pause to go back to look over one, that's great too. Okay, now 17, we're shifting it down 1. So all of these points we see should actually have been shifted up 1. Okay, so 4 should actually be 5. 9 should actually be 10. And I can't really see where I'm at. I guess that's 19, which should actually be 20. So we have 20, 10, 5. So we're dividing by 2, or timesing by a half. And we should have started at 5, so y equals 5 times 1/2 to the x, subtracting 1. Okay? And finally, number 18, this one got shifted down by 2. Okay, so looking at our points, we've got, this looks like it's at negative 1.5. This one would be negative 1, then 0, then 2, 6, 14. But again, because they subtracted 2, they should all be shifted up 2. So 16, 8, and we've seen these numbers. That was a positive 2, not a negative 2. So 4, and 2, and positive 1, and positive 0.5, which was my y-intercept. So we're starting at 1/2. So I go y equals 1/2 times, now, 1, 2, 4, 8, 16. We're times them by 2 to the x, which then we subtracted 2. Now, if those last ones are still like throwing you off, don't worry. We'll practice them, but we probably aren't going to be quizzed on them. In fact, I'll just say no, we're not going to be quizzed on those ones. Okay, I just want you guys to see kind of some harder stuff, which isn't bad either. Okay? All right, so you've had a little bit of time. You should be practicing these tomorrow, so you'll have more work linear and exponential, and you'll be creating some more equations, okay?